In the last video, I reviewed the following methods to generate a stream. In this coding challenge, you'll be using most of these methods to set up a few streams of your own. For this challenge, I want you to generate the bingo ball labels as 5 different streams using different stream creation methods for each. Assign each pipeline to a stream variable. Concatenate the 5 streams together. Apply the terminal operation for each to the final concatenated stream to print each label. These should be printed in order as follows: B1 through B15, I16 to I30, N31 through N45, G45 to G60, and finally O61 through O75. Remember that the map intermediate operation takes a function so you can return a different type than the input stream element. In other words, if you start with a stream containing integer, you can finish the pipeline with a stream containing string elements. To do this, you'd use map to return a string by executing a method or expression that takes an integer and returns a string. The generate method may be difficult to use without creating side effects or using other intermediate operations I haven't yet mentioned, but if you want a good challenge, you can play around with this one. It's time for you to give this a try, and when you're ready, come back and we can walk through my solution together. Pause the video now. Welcome back. How'd you do with that challenge? Were you able to create 5 different sources for the bingo ball label streams? Let's walk through one possible set of solutions together here. I've created a new project called Streams Challenge with the main class in the dev.lpa package. I'll start out with a local variable called seed and set that to 1. Remember that each set of balls has a different range of numbers. I'll use this variable to manage the starting index of each range. For my B labels, I'm going to use stream.iterate, the version that includes a predicate, because I think this is one of the easiest methods to use. First, I'll set up a variable with type inference, so var, and I'll call it stream_b. I'll assign it the result of calling stream.iterate. My first argument is seed, so in this case it's 1. I'll continue until the numbers generated reach 15, and I'll increment by 1 for each iteration. This is a finite stream. Finally, I'll map the integer to a string that starts with b, then is followed by the generated number. I'll test that out by adding a separate terminal operation. Running this code now. You can see that works, and I get the labels, B1 through B15. Okay, that's the first one, using the finite version of the static method iterate on the stream interface. Next, I'll work on the labels that start with the letter I. I'll insert this code before that last statement. I want to start by updating my seed value, adding 15 to that, because the range of numbers here needs to be 16 through 30. I'll call my variable streamI and use the 2-parameter version of iterate. I'll pass my seed variable and the same lambda for the unary operator as I did previously. Seed is now 16. Now here, I have an infinite stream. I'll include a limit operation, limiting it to 15 elements. I'll again use map to create a string starting with I and the value of the element in the stream. To test this, I'll change that last statement from stream_b to streamI. I'll run that to confirm I get the right labels. I could have used intstream for this. This time I get I16 through I30, so that's all good. Again, I'll include the next statements before that last terminal operation, first incrementing seed by 15 again. This time I'm going to use arrays.stream for my source. I'll create an array of strings with 15 null references. I'll call setAll to set the values directly here, with a lambda that is similar to the map operations on stream. Since my array already has everything set up, I'll simply create a new stream variable, streamN, and assign it the value of arrays.stream, passing it O labels. I could have used map on the stream, but it was just as easy to set the array up as strings as I've shown. But notice that I do have a problem with my lambda expression. My variable isn't final or effectively final, and that's fairly obvious because I keep changing it. This is a pretty easy fix. I can just create a second variable here and assign it the current value of seed. I'll set up a variable called nSeed and assign that the value of seed. I'll change my lambda to use this new variable, so I'll make that nSeed instead of seed. I'll also change that last for each operation to now print streamN. Running this. I've got N31 to N45 printing, so that's good and working as expected. You might be asking why I do this. This is sort of a forced example. but it's possible you join data from an array to other sources of streams. For the next one, I'm going to use stream.of. So again, first I'll increment seed by 15, and I'll put that before the last statement. This time it's a bit tedious, but it's a valid option. I'll create a variable streamg and assign it the result of stream.of. I'm just going to create a list of my 15 labels manually, one at a time, starting with G46 and ending with G60. I'll again change the stream being used for the terminal operation to streamg. Running that, I get G46 to G60. Okay, so that's 4 out of 5. Now I want to consider the infinite generate method that takes a supplier. What kind of supplier could I use to generate a list of 15 different numbers, all sequential? One way to do this is to create a static variable and a static method, which I'll do here. First, the static variable. I'll make it an int called counter and set it to 0. Next, I'll create a static method called getCounter. This will be private and return an int. It will return the value in the static field counter, then increment it. Now, getting back to the main method, I'll increment seed by 15 as usual. I'm also going to set up another local variable, setting it to the new value of seed, so I have an effectively final variable I can use in a lambda. I'll call this one streamo. That gets the value from stream.generate, and here I'm going to use a method reference that uses my static method getCounter. Because this is an infinite stream, I need to limit it, and I want 15 sequential numbers. I'll map that data to a string prefixed with O, adding rseed to the stream's sequential numbers. Next, I'll change streamg to streamo in the for each statement. That works, but I've created an intermediate operation that has side effects. This means this operation potentially changes the state of something outside of the process. Worse, it depends on that state being changed to function correctly. Remember that although I've specified how I want things to be handled in the pipeline, the optimization process might not see it as the most efficient way. In this case, all is well, but you should avoid producing side effects like this in stream pipelines. Shortly, I'll show you another way to use the generate method, but first, let me just finish the challenge. The last part of the challenge was to concatenate all the streams, finishing by printing all the labels from the concatenated stream. I'll insert this code before the last for each statement. I'll create an interim stream called streambi, and I'll use stream.concat to merge streams b and I. The next stream will be streams ng concatenated. Streambing will concatenate those two new stream variables together. Finally, I'll concatenate streambing with streamo. I'll chain for each directly to that, printing each element of this concatenated stream. Running this. I get all 75 labels printed, but I also get an error on line 44. I wanted to remind you that once a stream is used, you can't try to use it again. When I concatenate streams, this rule still applies. I concatenated streamo and executed a terminal operation on that concatenated stream. This used the streamo pipeline, so I can't execute this operation on line 44. I'll remove that last statement. Now the code runs without an exception. Okay, so let's revisit the generate method. Another way to do this is to use an intermediate method I'll be covering shortly and haven't yet demonstrated, called distinct. Maybe you discovered this operation on your own. It's always a good idea, when you're introduced to a new class or interface, to read the user's manual, which in this case is the Java API documentation. I'll show you now that I can create an infinite stream of randomly generated numbers in the target range, apply the distinct operation, and limit that to 15. Let me set this up at the end of the main method. I'll add a separator line first. I won't set up a local variable because I'll call for each directly in the pipeline. First I'll call nextInt on a new random instance, passing it rseed and rseed plus 15. This will give me numbers between 60 and 75 in an infinite stream. I'll next call distinct. This has no parameters and will allow only distinct numbers to pass through the pipeline. I only want 15 distinct numbers in my resulting stream. I'll map my labels, prefixing them with O. Next I need to sort my labels. Since they were generated in random order, I want them printed in sorted order. Finally, I'll terminate the pipeline and print each element. Running this, I have my labels from O61 to O75. Obviously, using iterate for this type of process was a better, more efficient operation. If you know what your number range is, and the start and end values are well defined, then use iterate. The generate operation is better at producing values until enough elements match more complex conditions that aren't dependent on a known range of numbers. I showed you an example of this with the prime number code when I wanted the first 20 prime numbers, and I didn't really know how many numbers it would take to meet that condition. Maybe you came up with a different way to use generate. If you did, make sure you post it in the Q&A. It's a lot of fun to see what others can come up with for these types of challenges. I'm going to make one minor change to this last stream, changing that bound from rseed plus 15 to rseed plus 14. I'll run this code. It runs, but it never completes, so I'll terminate that manually. Do you know why that happened? This random generator is only going to generate 14 distinct random numbers, but my limit operation is waiting for 15. This condition is never going to be met, so this really is an infinite situation. Even when you use the limit operation, if your operations and conditions aren't well thought out, you could get into a situation like this. Okay, I'll revert that last change so this code runs and completes successfully. I hope you enjoyed this challenge. I purposely wanted to limit the tools you could use in the challenge. Maybe you figured out how to use IntStream and either range or range close to generate a stream of integers and map it back to a stream of string. I'll be covering that, as well as other intermediate operations available to you next. I'll examine some of the ones I've introduced you to already in more detail, and I'll cover a few additional ones. I will see you in that next video.